Let's begin. Welcome everyone to the fight of the century. Today we are presenting Splink versus MDM. I'm Barney.
I'm Ash.
He's got less hair there.
I promise it's me.
Yeah. We both work for Simpson Associates. We are part of the local government team, and as part of that, we spend a lot of time discussing how you connect different record sets up, things like schools and social care data and police data and so on. But let's look at the plot for this session. We're setting the scene. That's what we're doing now. We're going to introduce you to the reigning heavyweight champion, Master Data Management. And then we're going to introduce you to the plucky upcoming contender, Splink. Conflict will ensue. Eventually, having evaluated their strengths and weaknesses, a grudging respect will form, and finally, in the last scene, there will be the inevitable team-up. Over to you, Ash.
Cheers, Barney. So, first of all, I'm going to talk about what record linkage is. It's a problem that we come across a fair bit, and that's when we've got to join together two unrelated data sets. And that's a problem when we don't have a common ID between the sources. If there's a common ID, you can join them together easy. We don't care about that. We want the hard problem. So on the right hand, I've got an example. We've got someone in hospital A, someone in hospital B. They've got slightly different names. Maybe they go by a nickname. Maybe there's some data entry issues there. So we can't immediately tell whether these are the same person. But we want to report on this data, so we do want to bring this together. We want to find that unique record, that golden record that links these two records. And we've come across this problem a fair bit when we're looking at things like single view of the customer, single view of the citizen, single view of the child, things like that. So first up, I'm going to talk about MDM. To take it from the top, what is MDM? Master data is data held by a business about its critical business entities like customers, products, suppliers. MDM, master data management, is a process of creating high-quality master data of those entities. I've got a diagram on the right showing us, we've got a few different customer names there, a few different definitions of what a customer is. We're going to shove those through the MDM process, and out the other side, hopefully, we'll get a nice, simple, single version of that customer. And it looks nicely spelled as well. So this customer that's come out the bottom, that'll serve as our trusted view of the business entity that we'll use for reporting or analysis or whatever. Now, MDM involves lots of different activities. You might do collecting, matching, deduping, transforming, QA, or distributing. And MDM solutions bring all those activities together into a single package so that non-technical business users, data stewards, can then do these activities within a friendly UI. I'm not going to go into too much detail here, don't worry. But just here's a few different overview implementation styles of master data management. On the far left, we are linking together a few sources, but not really doing any further transformations on those linked records. As we move further along, we're creating that linked view of the entity, but then maybe doing some further transformation. And then further along, we're linking those entities, creating that golden record, creating that master data, that high-quality master data, and then we're pushing that back out to the sources. So we're updating our source systems. So all these three approaches all require us to do some record linkage first. Or at some point in the process, there's record linkage. And on the far right, there's no record linkage, so we don't really care about that at the moment. This is an overview of how you might implement an MDM solution. We've got data sources on the left-hand side, and then we're using Data Factory to push that through to the MDM solution. And then from there, we can use it for reporting or analysis. Now, what are our options when we're picking an MDM solution? We've got a whole host of fully featured MDM solutions. I've listed a few there that we've used and know of. And on the right-hand side, if you want, you can do some kind of functional fit, see whether a particular solution is good for your business. And a typical solution might cost you about 75 to 150,000 pounds a year. We have found a cheeky little solution called Customer Insights, which is, it has some master data features. Basically, it's got some matching, the thing that we're talking about most at the moment. And it does some other stuff as well that we don't care about, but you can pay £17,000 a year and get that matching with that nice user-friendly UI. And that's a lot cheaper than the other options. So, in summary, the pros of MDM is you get a whole bunch of activities, you get some good quality master data out the other side of it. It's a non-technical GUI, but the cons are the data matching does have some limited flexibility. It's normally just a bunch of match rules with some fuzzy matching on top, and they are quite expensive. I mean, it's good to have good quality data out the other side, and that's really what you're paying for. But if you just wanted to do some matching, it is quite an expensive solution. So now we've talked about MDM. I'm going to hand over to Barney.
And on to Splink. Okay, what is Splink? Splink is a Python package developed by the lovely people at the Ministry of Justice. I've spoken to them, they are lovely, and I'm not just saying that because they'll be watching this on YouTube. Why did they do it? Well, unsurprisingly, the Ministry of Justice has a lot of data. It comes from multiple sources. It is very important for them to match the right person up in both those systems. Otherwise, very bad things could happen. So they set about finding a tool that would do it. It needed to be fast enough to link upwards of 100 million records. It needed to have a transparent methodology that they could explain to other users. It needed to be as highly accurate as possible, given the data quality, and flexible enough to accept a variety of data sources and match them all together. Asking for a lot, and unsurprisingly, they didn't find anything that matched their requirements, and so they built it themselves. They went to the government, they asked for a big pile of money, they hired some data scientists, and they built it. And fair dues to them, they achieved it. Where does Splink work? What do you need to get it going? I've said it's a Python package, and the only thing you need additional to that is it needs something at the back end to do that data processing. Could be DuckDB. That's your default approach. You can install it almost anywhere, you can run it almost anywhere. It's free, you can do it on your laptop. It's perfect for small amounts of data sets or development. They clearly lead with DuckDB. It's the most comfortable feeling solution. But at some point, you're likely to want to scale up. If you're throwing multiple millions of records at Splink, it's going to go a little slow on DuckDB on your laptop. And so it will run in Spark. It will use Spark as its background instead. And Spark, it could be your own clusters, it could be Databricks, it could be on Synapse. I generally have been running it on Synapse. I have not yet tested my scripts on Fabric, but I am going to assume that Fabric works very similarly to Synapse when I attempt this. Databricks, interestingly, has its own product called Arc, which is effectively a wrapper over the top of Splink. It's an interesting idea. Splink takes a lot of configuration. Arc tries to take a lot of that off you by doing some data science on top of the data science to find the best parameters. It will run elsewhere. It will run on these three: Amazon Athena, SQLite, PostgreSQL. You may not get the full experience. It will work there, it will feed in data, it will do its core matching process, but what you will find is the bells and whistles, the tools for string comparisons and so on, may not be there with those three. So how does it work? Well, We're just going to go on a very whirlwind tour of how you might match data. Number one, deterministic matching. Barney equals Barney. It has to be the exact same thing, all the same fields, and everything is the same, and that's good. It must be the same person, which is great, but it falls apart the moment something gets a little off. Next up, you'd encounter fuzzy matching. With fuzzy matching, we're putting a little bit of flex into our comparisons. So here we've got Barney with an EY, we've got Barney with an IE, and we can see that there are two character changes to get from one to another. We've got a value of 2, that's the Levenstein distance, we can use that function, and so in our comparisons, we can say not just that it's the same string, but it's a similar string. But with fuzzy matching, we're still under the covers deterministic. We're joining, we're checking that, we're hard coding for an exact match for 1 character difference, 2 character differences. Splink takes a different route and uses probabilistic matching. We're not thinking about individual columns, we're not thinking about individual rules, we're looking at everything and we're working out what is the most likely matching. How does that work? Last time we explained this, it took 1 hour and 15 minutes of our hour-long session, so I'm going to have to go fast. If you want more detail, search out our video on the festive tech calendar. There's a lot more in there. Here we've got data set, and I've given everyone one of two properties. Blue and red, kilts and trousers, male and female, it doesn't matter, as long as you know there's a bunch of them, and it's a 50-50 split. If I choose 2 random people who are not the same, what is the chance that this value matches? It's 50-50. It's a coin toss. Pick the first one. Half of them will be the other, half will be the other half. It splits down the middle. What happens if it's the same person, though? If this is the same person in 2 different record sets, what's the chance of it being the same? What's the chance of it being different? Well, it's much more likely to be the same than it is to be different in this case, because it's the same person. But it's not 100% because data quality happens. People leave blanks, people make mistypes. Splink works this out for every comparison you ask it to do, for every field it looks at, and then it builds it up, it calculates these probabilities, and it uses that to produce a weighting, a likelihood that this happening in the data signals it's the same person or it's not the same person. And we end up with a great big chart like this, showing all those weightings. I'm just going to focus down on the postcodes here because they're the clearest. So we see that bar here. If the postcode is exactly the same, that's a strong signal that it's the same person because they live close to each other. Next down, it's the postcode sector. It's a similar postcode. It's nearby, but it's not quite the same. Splink thinks that's quite a sign it's the same person. Maybe they mistyped the postcode. Maybe they just moved a short distance. And the further and further away those 2 postcodes are, the less likely the person is in the match. So that weighting goes from a positive to a negative. Once it's done, we just add them all up. It builds some nice little water charts for you. Start off negative, because 2 random people probably aren't the same person. If the forename matches, we go up a bit. If the last name matches, we go up a bit. If the postcode is the same, we go up a bit. If, say, the date of birth is different, we might go down a bit. Ultimately, we end up with a single weighting showing the strength of the likelihood that those 2 records are the same. And we can then use that to find the best possible matches in our data sets. Splink has one more trick, because if I have a data set with 1 million people and another data set with 1 million people, and I'm just working out the probabilities for all of them, I have to do that many calculations. I've worked this out for you and come to the conclusion it's a very big number. And it would take a very long time to process. And so Splink gives us the concept of blocking. If you think about the data, the chances of someone whose data is completely different from another record being the same person is near enough 0. So we're going to cut our chances a little bit. We'll say join on last name. Assume last name is exactly the same, and then work out the probabilities for the rest of the columns. Then we'll join on first name, in case the last name was a bit fuzzy, and we'll do the same. And we keep on doing these blocks to squeeze things down to massively reduce the number of comparisons we make without significantly reducing the chances of missing a match. So in summary, what's good about Splink? What's bad about Splink? Good thing about Splink, it is cheap. It's very, very fast. It's very, very powerful. There are a lot of options for configuring it and choosing your comparisons. What are the cons? Well, it takes quite a bit of technical skill. You need somewhere to run it. You need to know a bit of Python. You need to understand the data. You need to potentially know a bit of regex or SQL. And the other issue is it lacks a friendly front end. It's generating weightings, it's giving you a bunch of numbers, and it's dumping it into a table. It's for you to work out what you do with that afterwards, which is great for data people like me. It's less good if you're an admin who just wants to click buttons and say, yes, that's a good match. Over to you, Ash.
Cheers. So our two warriors have been fighting each other for a little while now. You might be wondering who's won. Well, through this fight, they've realized that where one of them is weak, the other one is strong. So throughout all that, they've come to realize that the town is big enough for the both of them. And actually, there's use cases for one, use cases for the other, and sometimes use cases for both. So thanks very much for listening. We've been Barney and Ash. We work for Simpsons. We're down in the hall if you want to say hi. And that's it. Thank you very much.
Yeah. We do actually have... We have spoken remarkably fast. If anyone has any questions, do raise them. We were expecting to hit 20 minutes at exactly this time.
We've got about 3 minutes.
2 minutes 41. Yes.
Thank you.
So just wanted to make sure I understand it correctly. So the probabilistic matching approach with Splink basically works over multiple fields, so you have like first name, last name, postcode. And if you only have one field, is there any advantages of Splink versus the fuzzy match, for example?
If you only had one field, then yeah, I suppose the advantage of doing Splink on one field. No. Sorry, I'm going around in circles. The problem with one field is how you would train it on the fuzziness. It could understand things are exactly the same, but to understand something with one character difference is the same, you need to introduce something else. It does have the concept of labeling fields, so if you were to manually match some of those misspellings and differences, you could use that subset where you had already approved the matches to get it to come up with a probability that other drifts in lettering were the same. And I don't know how much it would add, but it would give you a weighting so you could rank them. You could say this is a really close match and this is less of a match, whereas if you were just doing the fuzzy matching, you wouldn't necessarily get the more analog approach to that list of these are our really strong likelihoods and these are our lower likelihoods.
I think the probability wouldn't kick in, basically. I think you would need multiple fields, yeah. Yeah, at the back. The question was, how do we see Splink and MDM working together? I think what we would imagine is, instead of doing the matching within MDM, you would push the data out to Splink, it would do the matching, and then you'd send it back into the MDM, which is what we do a lot of the time when we don't use MDM, we just send it out to Splink, bring it back.
Yeah. MDM is your day-to-day. Splink is your big once a week, once a month. Let's cache those hard-to-find cases.
Yeah, and one question at the front. Question was, sorry, they've just said time. Are there reports for things that don't get matched? Were you about to say something, Barney?
So what I was going to say is Splink doesn't say, yes, this is a match, no, this is a match. It gives you a weighting. So So there will be ones at the top where, yes, I'm really confident there's a match. There will be things at the bottom where there's some kind of similarity. There's a reason it's paired them up, but it's a really low probability. So I think those are the ones you'd be looking at.
Okay, and is it possible, like, to get kind of a connection link between this data who probably match? Like, okay, this guy could be this one, and then I get a list or a report. Like, okay, I have this, and the other things I don't know.
You could build it from the output.
Ah, okay.
You could build a report on who matches and who's the most likely to match from the output.
Yeah, thanks very much. I don't think we have time for questions, but
I'm happy
feel
to
free
chat
to
afterwards.
chat afterwards. Yeah.
Thank you.